resolving vectors. So the reason why we need to resolve a vector, or what resolving a vector means, is that we're going to be given a certain amount of information, but we want to turn that information into a vector. So in terms of I and in terms of j, so having its I horizontal component and its j its vertical component, so that when we have it like that, when we have a piece of information like that, what we can do is we can add and subtract vectors together, and this will allow us to find we'll say like the velocity of A relative to B, because we know that we can take the velocity of A, subtract the velocity of B in terms of their I's and J's, and then we can go ahead and get magnitude, direction, stuff like that. So when we're looking at resolving the vectors in this case here, the first one that we're looking at is the velocity of a car is 10 kilometers per hour, so it's going 10 kilometers per hour, the speed of it. It's in the direction of 80 degrees north of east, and we want to write this in terms of I's and J's. So the first thing that we're going to do is we're going to take a look at what this actually looks like. So I'm going to draw my little north, south, east and west. I know that these are my I's and these are my J's. The velocity of the car is 10 kilometers per hour, so that's going to be our hypotenuse value. It's in the direction 80 degrees north of east. So remembering that north of east, it means you are always starting at the east and you are going north of it 80 degrees. So it'll be something along the lines of that. I know that the angle there is going to be 80 degrees. Make that a bit clearer. Okay, so we have our angle of 80 degrees. I know that this is going to be 10. And what we're going to do is we're going to try and split that up into its I and j components. So I'm going to make this into a right angled triangle. So here we have a right angled triangle, and this right angled triangle consists of this hypotenuse, and then we have our adjacent and our opposite. So to do that, we are going to use sine, cos and tan to find our opposite and find our adjacent. So our opposite is going to go with sine. So it's going to be sine of an angle is going to equal opposite over hypotenuse. So that angle is 80. So sine of 80 equals our opposite over our 10, our hypotenuse. I'm going to bring that up. That's going to become 10 sine 80 equals our opposite. Make sure that we don't think that's a 0. So 10 sine 80 then is going to be 9.85. And that's our opposite. We're going to do the exact same thing for our adjacent, but instead we're going to use our cos. So cos of that same angle is going to be A over h. So that's going to be cos of 80 is going to be our A value. We don't know, but we know our h is 10. So that is 10 cos 80 equals to our adjacent 10 cos 80. I put the whole thing in the calculator, getting 1.74, and that is our adjacent. So because my adjacent goes along the I, then I'm going to have that as 1.74i, and my opposite is going upwards, and that is going to be plus 9.85j, and that is that vector resolved. So that part there is my resolved vector. And what we can do then is, if we were given another one of these, we can resolve it as well. We can subtract them then to find our velocity of, we'll say, A relative to B, or whatever they are. Let's take a look then at the next type then. So this one here is the velocity of the car A is 12 kilometers per hour in a southwest direction. So they're not giving us an angle there. And if they're not giving us an angle, all we have to do is we have to take it as that angle is going to be 45 degrees. So this is going a southwest direction. So it's going southwest direction. I'm going to make it a little bit more like that. Okay, and again we have north, south, east, and then we have west. And we know that this is our J's and this is our I's. I'm going to write in my vector. I'm going to draw in my vector. It's going to be that. I know my angle is going to be 45, and they've said that this is 12 kilometers per hour. Again, I'm looking to resolve it, so I'm looking to change it into its i's and j's components. So I'm going to draw this down and I'm going to create a right angle triangle where this is going to be my opposite and this is going to be my adjacent. And I'm going to use the information that I have there to find the answer for this. So my opposite and my adjacent, then for my opposite, I'm going to use sine again. So sine of my angle is 45, is equal to O over H, so opposite over 12. So that's 12 sine 45 is equal to my opposite. And that is going to be 6 root 2. Okay, I do the exact same thing with cos 45 is equal to my adjacent over 12. That's 12 cos 45 is equal to my adjacent. Because cos 45 and sine 45 is the same thing, they're going to come out to be the same. And also because 45 would mean that this is also 45, so we'd have an isosceles triangle. So it's going to be 6 root 2i and, 6 root 2j. Now what we have to be careful of here is my signs. So what signs are we putting where? Because it's going in a west direction, the I is going to be negative. Because it's going in a south direction, my j is also going to be negative. And that's my answer for that second part there. Okay, let's take a look then at the next two parts. There's only two little parts left and that's it done. So same idea for this one. We have the velocity of car B this time is 26 kilometers per hour, travels in the east. A is the angle there, and the little dash just is a symbol for degrees that I'm using. And we have tan A is equal to 12 over 5. Find the velocity of B in terms of I and J. So same idea as before. I'm going to draw out this here. And I'm going to say, okay, so it's going east, A degrees north. So I'll make that a little bit bigger. So if it's going east and north, then I'm going to make the east and the north a little bit bigger just on this diagram. So I have my north, south, east, west. There's my J's, there are my I's. Okay, I don't know what that angle is, so I'm going to put in A. I'm just going to put in a little alpha symbol there. Okay, or A, whatever one you want. They have said that this is 26. And I'm doing the same thing. I am resolving that vector with my 90 degrees. There's my opposite, there's my adjacent. The only thing that they have told me extra here is that tan of A is equal to 12 over 5. Make that a bit clearer. Now what that tells me is if I have tan of A equals 12 over 5, I'm able to find other bits of information. So if I have this here, tan is O and A, then that means that this is my angle here. My O is going to be 12 and then my A is going to be, my A is going to be 5. So if I do Pythagoras there, I can find that this side here is going to be 13. Now if you look at this, we can tell that all I have to do is double them all. But let's just go through this as if these are going to come out as quite unusual numbers. So what I can say here then is that if my tan of A is that, my sine of my angle is going to be opposite, which is 12 over 13. Make this a little bit clearer. And I can also say my cos of A is going to be 5 over 13. And that is just using the fact that I know this is O, A, this is H, and I know that I have SOHCAHTOA then as well. Okay. So I can now use this information and I can say, well, if I'm looking to find this angle or this side here, that I have the sine of my angle equals O over 26. That's 26. Sine of my angle I know is 12 over 13. And that is going to give me 12 over 13, and that is 24, isn't it? Because then divided by 2, yeah. 24 equals my opposite. I do the exact same thing with my cos of my angle equals A over 26. And then I'll have 26 cos of A is 5 over 13. So A is equal to 10. So again, I know my A is 10. That means that when I'm writing this out as a vector, the A is going to be 10i. I'm going to have 24j. I'm going plus the I and plus the j, and that is my vector resolved. Okay. The last one then, this question here. Now, they're all pretty much similar after this, but with this one, I'm going to just go through it a quicker kind of way rather than having to write all this out all the time. It's a little bit easier to kind of just go through it and get it all done in kind of 1 or 2 steps. So if I look at this question here, I have the velocity of A is given a speed of 3 root 2 and has a direction of tan inverse. So that is tan inverse 5 over 12. Now that means same as this one here. I have tan that's O1A. So if I have tan of O1A, then that means that my sine of my angle is going to equal, and my cos of my angle is going to equal. Sine is opposite, cos is adjacent over, and the hypotenuse is going to be 13 again. Okay. The next thing I'm going to do then is I'm going to write A equals, the velocity of A equals, I write 3 root 2, and I write cos of my angle and I write 3 root 2 sine of my angle j. Okay, cos always goes first, sine always goes second, I is first and j is second. You always put then the speed there and there. And the last thing we have to pick out then is which direction is going. It's going south, so that means if it's going south, my j's are going to be minus. It's going west, so that means my i's are going to be minus. And all I have to do is fill in these parts over here. So it's going to be minus 3 root 2. Cos of theta is 12 over 13i minus 3 root 2. And it's going to be 5 over 13j. So A there, I'm going to just write it to 1 decimal place. Minus 3.9i and minus 1.6j. So to start with, I would be doing this way where you're writing everything out, making sure that you understand why you're using sine, why you're using cos. And eventually then all you have to do with these is just your speed. Check what direction you're going for the minus and the plus. You're always putting cos with the I, and you're always putting sine with the j. And you're just filling all the information in then.